Okay, welcome. Now they're asking, if C is 13 and K is equal to 6, what is the transient portion of the general solution? Okay, so we'll have our model here, which is going to be x double prime plus 13 x dot, so x prime, plus 6x, that's equal to 12 cosine of 2t. Now let's solve the homogeneous. Let's check for linear independence. So we have to solve the homogeneous. We can say this. So what are two numbers that multiply together are equal to 6 and added together equal to 13? So now, because our complementary solution is C1 times e to the negative 6t plus C2 e to the negative t, this is our transient part of the solution. Now you might be asking, well, how did you know? Well, what is the transient? That's the part that dies out with the time. As you see, these are negative. So as we go with time, or that increases with time, I think. So as you see, these have negative coefficients. So as time becomes larger and larger, these numbers become smaller and smaller, and they don't matter anymore. And all that matters is that particular solution that we should find, which they're not asking us to find right here. They're asking us for the transient part. So, but if we were to find it, now our initial guess of a cosine of 2t plus b sine of 2t actually works because we don't have anything that looks like that in the homogeneous solution. So that's where you would get the part that doesn't die out. But this part will die out eventually. And that's the transient response. So what is the transient response portion of the solution? And they're not giving us initial conditions, right? Let's double check. No, they're not giving us initial condition. They are not giving us initial conditions. I'll write it here. They aren't giving us initial conditions. So we'll leave the constants. And so our transient part is going to be the complementary solution, which is going to be C1 e to the negative 6t plus C2 e to the negative t. All right, I hope this was useful, and I will see you next time.